Okay, let me do a example problem from two-dimensional motion to the circular motion, first WebAssign on circular motion. And why don't we go ahead and just do number one here. So we have an insect on a platform that's spinning around. You'll notice that my drawings are going to be terrible, so I'm not even going to worry about it. But basically it's 2 meters, so this is a radius of 1 meter. 1 meter. And the question is, let's see, apparatus studies insects at an acceleration of magnitude whatever. I have 970 meters per second squared. So I've got an acceleration equal to 970 meters per second squared. All right. And the rod rotates about the center. How fast does an insect move and experience a radial acceleration equal to that? Well, basically we have acceleration centripetal is v squared over r, over the radius. So how fast? We're looking for v, solve for v, square root of ar, and that's equal to the square root of 970 times 1, which is 31.1 meters per second. So there you go. That's how you do that. What's the angular speed of the insect? Angular speed. Now, angular speed is a new concept, and we have regular speed. V is equal to delta x over t. Well, there's a relationship with angular speed. If we got an object moving in a circle, radius r, and it's moving at speed v, there's a angular velocity omega, and it relates to the radius simply as follows, namely that omega is equal to v over r. So another way to think about that is v is equal to omega r. So the speed goes up. If you're going around the circle, if you're going around a circle here, or a greater radius, it goes faster. If it's moving around, if it's a rigid object going in a circle, the greater your radius is, the greater the speed is. And that's what this is showing. It's proportional to the radius. So omega is equal to v over r. So in this case, we had 31.1 meters per second. The radius was 1, so that's 31.1. Now, the unit is basically, it's the angular velocity, so it's the angle per second. So the unit is, the standard unit is radians per second. So there's how to do problem number one on that WebAssign.